अगर दोनों का एक ही सोल्यूशन आ रहा हो तो हम उन दोनों जो इक्वेशन है इस सिस्टम को हम कहेंगे कि दिस हैज अ compatible system. Okay, and there is a theorem, and this theorem says that how to check this thing. Okay, so the equation, if we have equations which is a1 and a2, which is defined by f equals to 0 and g equals to 0, and this equals to 0, these equations are compatible on a certain domain. Okay, so suppose if we write a domain D, on a domain D, if this satisfies two conditions. First one, the Jacobian, that is a partial of this f and g, this partial of f and g, p and q. ओके, तो g q में थोड़ा सा डिफरेंस है, देख लीजिएगा कहीं कंफ्यूजन ना हो. ओके, इफ दिस जैकोबियन मींस यू नो दैट इफ दिस फंक्शन f is differentiate partially with respect to p, f is partial differential with respect to q, and then g with respect to p and g with respect to q. If this Jacobian is this is non-zero on that domain. Okay, so if this is non-zero, and second one, if our p and q can be explicitly solved from these two equations, and this equation okay, a1 and a2, this from equation a1 and a2, as this p can be function of say x, y, z, or from this equation, and suppose we are using these two, and you can find this p and q explicit form of x, y, z. Okay, so suppose this is the another function, say we can say psi of x, y, z on solving a1 and a2. If this, then further you know that what is your solution. So further the equation, that equation is your if we write dz, this equals to phi of this is basically p of dx, q of dy. Okay, this is integrable. So this p means this function phi x, y, z. हाँ बताएं
सर किसी को एडमिट कर लीजिए.
अच्छा, ओके 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 ओके. अच्छा, ये नोटिफिकेशन हालांकि आती है, एक बीप की आवाज आती है, बट हो सकता आई हो हमने ध्यान न दिया, सॉरी है. तो ओके, तो ऐसा कोई हो अगर और भी वेटिंग में, और हम अगर हमारे माइंड से अगर हट गया हो तो आप हमें ऐसे ही बता दिया करिए, क्योंकि हमारे क्लास में कोई ऐसे टाइमिंग की कोई इशू नहीं है. आप जब चाहे तब आ सकते हैं. इवन आप 10:55 पे भी आप एंट्री कर सकते हैं, हम एंट्री दे देते हैं. ओके, सो हियर this dz, which is a phi of dx and psi of dy, this is integrable. Okay, so this is integrable. Okay, so this is integrable. This is right here, this is integrable. Okay, so this is your first theorem. Okay, और हम इसकी प्रूफ पे हम नहीं जा रहे हैं. Okay, सेकेंड थ्योरम, नेक्स्ट पेज पे हम कंपैटिबल के लिए नेसेसरी सफिशिएंट कंडीशन क्या है कंपैटिबल के लिए, तो एक थ्योरम और है, तो हम आपको नेक्स्ट पेज पे ले चलते हैं. तो नेक्स्ट पेज ओके, सो नेक्स्ट पेज पर हम चलें और यहाँ पे हम सेकेंड थ्योरम की बात करें, एंड देन गो टू द प्रॉब्लम. ओके, सो व्हाट इज द नेसेसरी एंड सफिशिएंट कंडीशन? सो नेसेसरी and sufficient condition for this integrability, that is dz equals to p dx plus q dy. So this is necessary and sufficient condition for integrability of the equation and that equation is dz equals to p. P is the function of x, y, z, explicit form you can find here, and here q is the another function of x, y, z, this dy. This is the integrability of that is the bracket f and g, bracket of f and g, and this is 0. Bracket sense that bracket means the Jacobian of f g with respect to xp plus Jacobian of f and g with respect to y and q, okay, and plus this plus p of Jacobian fg with respect to z p plus q del over fg with z q. Okay, so this is q. Okay, this is q. Okay, so this equals to 0. Okay, if bracket equals to 0, then your f and g is compatible, and if this f and g is compatible, then this integral exists, and you can find the integral of that. Okay, suppose this is your equation a1 a2 already have defined kar rakhe hain. This is a3. Okay, so in other words you can say this theorem. So in other words, the equations, that is a1 and a2 are compatible. This is compatible if and only if and only if the whole. Okay, so you say that this f and g are compatible if this bracket equals to 0, and bracket means fg with respect to this is x and p, and this is xg is y and q. Okay, and then if we take z के साथ अगर हमने तो p हो जाएगा, और अगर q के साथ दे रहे हैं तो this is q multiplication. Okay, so if this bracket equals to 0, then we say that this is compatible. Okay, so now if we take example, and if we say that the two equations, if we take two equations which are linear or non-linear, okay, suppose this xp minus yq equals to 0, and second one, if we take z of xp plus y of q, that equals to 2xy. Okay, so there are two equations, and we say that we check that this system are compatible or not. Okay, so this system is compatible, and if this is compatible, then this is integrability condition exists, and then you find the solution. Then this when you integrate this equation, you can find easily what is the value of z. Okay, so and solve them. So first one, you have to check this compatible or not, and then solve this equation. Okay, so here we have to find what is your f and g. So we have to take what is your f. So we have defined f, which is the function that f equals to 0, that is the function of x, y, z, p, and q. So this is your function xp minus yq, that equals to 0. This is your function f. What is function g? So g is the set of xp plus yq minus 2xy, that equals to 0. So you can find this function f and you define this function g. If these two are compatible, if this equation a3 holds, this means you have to find these partial derivatives and put here and try to find what is the bracket of this f and g. If f and g is 0, then these two equations are compatible. Then you have using these two equations, and you can find the explicit form of p in terms of x, y, z, and q in terms of x, y, z. Then putting here, this is your p, this is your q, and then you find dz equals to p dx plus q dy, and then integrate that, and you can find the जनरल सोल्यूशन. ओके, सो ये सारी चीजें हम क्या करें, हम नेक्स्ट पेज पे हम ये सारी चीजें करते हैं. ओके, so here if this thing holds, okay, तो यहाँ पे से जगह है, तो we can find what is the partial derivative with respect to x here. So if you differentiate this partial with respect to x, you get p. If you differentiate with respect to y, you get minus q. If you differentiate with respect to z, you have 0. If you differentiate with respect to q, this is equals to minus y. If we differentiate this term with respect to p, so this equals to x. Okay, so these are the partial derivative here. Okay, and here what is your, if you partial differentiate with respect to x, you get zp minus 2y. If the g, this is g, okay, the g of y, you have zq minus 2x. What is z? xp plus okay, yq. And if we differentiate with respect to p, this is zx. If we respect to q, is g with respect to q, this equals to zy. Okay, so these are the values. So you have to find these partial derivative, and these are the partial derivatives of with respect to x, y, z, p, and q of f and q respectively. Okay, so here you putting these values in equation a3, and then try to find what is the value here. So first of all, you have to find the Jacobian of that is non-zero. So first of all, we have to find this Jacobian is non-zero or not, and that domain. Okay, so here domain is not given, so we have to check here for non-zero x, y, z, because if x, y, z are 0, that 0 equals to 0, so no meaning of that partial differential equation. Okay, so we have to find the Jacobian of f and g with respect to p and q. This is non-zero, and then further we have find the bracket of that is equals to 0. So next page, we have compute the Jacobian j. So here, what is j? So j is your Jacobian of f and g with respect to pq. So this is f and g with respect to pq. So this equals to, this is fp, fq, gp, and gq. So if we putting these values, so x, this is minus y, and this is x, and here minus y, and here zx and zy. So if we solving this is zxy plus zxy, that is 2zxy, and this is basically non-zero for x is not equals to 0, y is not equals to 0, and z is not equals to 0. Okay, so this is non-zero. Then further we have find the bracket of fj. So further, what is the value of bracket? So we need to compute f and g with respect to pq. Okay, तो हमने already निकाल लिया. This is xp, this equals to, and we have to find the Jacobian of this with respect to in our bracket equation. So zp, and what is the value of f and g with respect to yq, and then the Jacobian of fg with respect to zq. Okay, so here we can solve these values, and then you find what is the bracket of f and g. So f and g is basically fg with respect to xp plus fg with yq. Okay, then plus p times this one, f and g with zp, and q times this one, this is f and g with zq. Okay, and this values we putting here, and then check this is zero or not. If this is zero, then this equation are compatible. Then we have find the solution of that. Okay, so here this value is basically this value is 2xy. This value is minus x square p minus xy q, and this value is minus 2xy, and this is y square q plus xyp. Okay, so if we putting these values here, so this becomes 2xy minus x square p square minus xy pq minus 2xy plus y square q square plus xy pq. Okay, so this equals to here what is the value of f? So f is xp minus yq, that equals to 0. Okay, so this means xp equals to yq. So from f is this thing, so xp equals to yq. Okay, so if here this term xypq and xypq is cancelled out. Okay, and here 2xy and 2xy are cancelled out. So basically here you have minus of x square p square and y square q square, and from here you get this equals to 0. Okay, so this means your equations, given equations f and g are compatible. This is compatible. Okay, so here our next step to determine the solution. Okay, so here we have to find the p and q. Okay, so the next page we have find the solution of this compatible system. So on next page we take what is the value of p and q. Okay, so here f and g are defined in the form of x, y, z, and p and q. Okay, so from there we can calculate what is the value of p and q. The next page. Okay, so next step to determine what is p and q from the two equations. That equations are xp, that equations are xp minus yq, that equals to 0. Basically this is your first equation, and second one is z xp plus yq, that equals to 2xy. This is your second equation. Okay, so from equation A, A से हमें क्या मिल जाएगा? तो A से हम लिख सकते हैं xp. ओके, सो ओके तो हमारे पास ओके, सो हियर okay, so here we have this z of xp plus z of yq minus 2xy, this is equals to 0. So this implies we can write here this xp plus yq, this equals to 2xy over z. Okay, xp plus yq, and here xp minus yq. Okay, so from first ओके, तो यहाँ से हमें फ्रॉम ए से हमें क्या मिल जाएगा? ओके, तो यहाँ से हम लिख सकते हैं कि योर xp इक्वल्स टू yq. So this implies suppose this is your equation C. Okay, so this implies equation C implies if two are same, to 2 of xp, because yq equals to xp, so this equals to 2xyz. So we can find p in explicit form, so 2x are cancelled out, so this is simply y by z. Okay. So this implies y by z, and this is a function of x, y, z. आप लिख सकते हो, this is x to the power 0 and y to the power 1, z to the power -1. Okay, ठीक है. And second, we have from equation A. This ये चीज तो है ही आपके पास. So here xp equals to yq. So this implies what is the value of p here? So suppose this is equation D. Okay, so this implies equation D से आपको मिल जाएंगे. So this means x and p is y over z. This equals to yq. So this implies q equals to y are cancelled out. This is x by z only. Okay, and this is the function of x, y, z. This is equation E here. Okay, so we have to substituting this value. So substituting p and q in our this dz, that equals to p dx plus q dy, or you can say dz equals to phi of xyz dx plus psi of xyz dy. Okay, so here you get dz is equals to p. P means y over z dx plus this is x over z dy. Okay, so this implies you can write here z of dz, this equals to y of dx plus x of dy. Now if we integrating this, so we can this z square by 2, this equals to x dy y dx. So this is simply d of xy, d of xy, x into y, d of x into y. So if we integrate that, this is xy plus integration constant c. What is here z squared? Z squared is 2xy plus something constant k. Okay, so this is your final solution. Here k equals to 2c, so c with the constant one, so k with the another constant. Okay, this k is constant. Okay, तो इस तरह से आप उसके solutions आप निकाल सकते हो. So here the main remark is for compatibility of f that equals to 0 and g that equals to 0, okay, is not necessary that every solution of f equals to 0 be a solution of that equals to 0 or vice versa. Okay, तो अगर दोनों के एक ही solution है तो हम ये कहेंगे कि वो हमारा जो है वो कंपैटिबल है. लेकिन अगर वो कंपैटिबल है तो हम ये नहीं कहेंगे कि वो दोनों के जो सोल्यूशन है वो हमारे दोनों के सोल्यूशन जो है वो कॉमन सोल्यूशन होंगे. ओके, तो मतलब इसका जो कन्वर्स पार्ट है वो ट्रू नहीं. तो हम चाहे तो आप उसे नोट कर लें. नेक्स्ट पेज इन फॉर्म ऑफ नोट हम लिख सकते हैं. तो नेक्स्ट पेज अगर हम लिखें इसे, there is a remark basically. So for the compatibility of f equals to 0 and g equals to 0, okay, it is not necessary that every solution of this f be a solution of this g. Okay, or vice versa. Okay, so this not sense that every solution of this be a solution of that. Okay, so compatibility means if there is a have a common solution, अगर एक भी इसका common solution मिलता है तो this means that these two are our compatible. Okay, so next है आपका for non-linear partial differential equation solve करने का, and that method is well-known method, and this method is Kapit method. Okay, so this is Kapit's method, And here, this is basically the general method. So you can write here, it is a general method. It is a general method for finding the complete integral, okay, of non-linear partial differential equation of first order of the form, and that form is f of x, y, z, p, q that equals to 0. Okay, so this is your general form of any non-linear first order partial differential equation. Okay, so what is the auxiliary equation, or you say what is the Capet equation? So the Capet equation, the Capet equations, यहाँ आप इसे कार्पेट इक्वेशन भी कहते हैं, और कहीं आप इस मेथड को चारपेट भी बोलते हैं. ओके, तो डिफरेंट इसके प्रोनाउंसिएशन है. ओके, सो बहुत जगह आप इसे चारपेट भी कहे जाते हैं, ठीक है, और बहुत जगह से आप कार्पेट भी कहते हैं. तो आप मेरे ख्याल से अब चारपेट मेथड ही ज्यादा जगह यूज होते हैं. ओके, तो डिफरेंट डिफरेंट बुक्स में आपको डिफरेंट डिफरेंट मतलब कि लेक्चर्स में आपको मिलेंगे. तो चारपेट भी से कहते हैं और कार्पेट भी कहते हैं, तो कंफ्यूजन नहीं रखना. ओके, पर ज्यादातर चारपेट मेथड आप सुनेंगे. ओके, सो दिस कार्पेट इक्वेशन और बेसिकली ऑक्सिलरी इक्वेशन. ऑक्सिलरी इक्वेशंस आर ओके. सो जो इक्वेशंस है इसकी पूरी डेरिवेशन है. ओके, पूरा डेरिवेशन इसका, बट हम यहाँ डेरिवेशन नहीं, सिर्फ हम आपको फॉर्मूले दे रहे हैं, और इस फॉर्मूले पे डिपेंडेंट आपको प्रॉब्लम्स करनी है. ओके, हालांकि आप डेरिवेशन जानते तो अच्छा ही था, लेकिन इतना समय नहीं है, और ना आपके सिलेबस में है इतनी सारी चीजें कि पूरा आपको थियरम और उसकी प्रूफ ही कराते जाए. तो इसलिए थोड़ा आप न्यूमेरिकल भी आप करें. सो ये अंडर ग्रेजुएट में चीजें पाई जाती हैं, और अंडर ग्रेजुएट में बहुत सी जगह ये ऑलरेडी आप ये चीजें पढ़े हो. तो हाँ, अंडर ग्रेजुएट में इसकी प्रूफ नहीं कराई जाती. ओके, बट अंडर ग्रेजुएट में इस तरह की इक्वेशंस दे देते हैं, और इसमें नहीं कराई जाती है. बहुत सी हमारे देशों में ये चीजें अंडर ग्रेजुएट में है. ओके, तो जहाँ नहीं हो उनके लिए है कि ये हमारे पास जो चारपेट इक्वेशंस है या ऑक्सिलरी इक्वेशंस है वो इस तरह से डिफाइंड होती है. दिस dx ओवर दिस इज fp means this differentiate is equal to partially p, this is fq partially different q, this p plus q. Okay, and here minus of fx plus p fz, and here minus of fy q fz. Okay, so you have to solve डिपेंडिंग ऑन कि क्या आपकी प्रॉब्लम होती है उस हिसाब से आप ले लें. वहां पे आपको फाइनली आपको निकालना क्या है, तो फाइनली आप यहाँ पे इसको सॉल्व करेंगे, और यू हैव टू कैलकुलेट व्हाट इज द वैल्यू ऑफ dz. ओके, एंड dz इज बेसिकली p dx plus q dy. ओके, तो आप उसको इंटीग्रेट कर लें और सॉल्व कर लें. ठीक, तो एक प्रॉब्लम हम उसकी कर लेते हैं, एक प्रॉब्लम हम करते हैं, हमारे पास टाइम भी सफिशिएंट है. तो नेक्स्ट पेज पे हम इसकी न्यूमेरिकल ले लें चारपेट मेथड की, और उसको सॉल्व करें. ओके, तो ओके, नेक्स्ट पेज. हाँ हाँ, बताएं, बोले. हेलो,
शायद गलती से उसका
क्या क्या हुआ, कोई बात है?
सर नहीं तो कोई बात नहीं है.
ओके, ठीक है, तो हम नेक्स्ट पेज चल रहे हैं. ओके, नेक्स्ट पेज. ओके, so find the complete integral और आपको ढेर सारी, अगर आपको सॉल्व प्रॉब्लम चाहिए या एक्सरसाइज के लिए चाहिए, तो आप एमबी राय सिंघानिया की पार्शियल डिफरेंशियल इक्वेशन की बुक है, उसमें आप देखेंगे तो बहुत ढेर सारी आपको एग्जांपल्स मिल जाएंगे। ओके, तो पार्शियल डिफरेंशियल इक्वेशन की जो भी हम आपको लीनियर नॉन जो भी करा रहे हैं, इवन आगे भी अगर हम सेकंड ऑर्डर पार्शियल डिफरेंशियल इक्वेशन करेंगे, केमिकल फॉर्म करेंगे, ओके, और हम ऑर्डर की है में न्यूमन में, ओके, तो वो सारी चीजें आप एमडी राय सिंघानिया बुक में आप वो पोर्शन पूरा देख सकते हो, पूरा पूरा पोर्शन आपको मिल जाएगा। ठीक है, तो ओके, सो फाइंड द कंप्लीट इंटीग्रल ऑफ this p square x plus q square y that equals to z. Okay, so suppose this is your problem, and here we suppose what is your f here. So equals to 0. This is your f. Then you have to calculate what is the f of x. Okay, so this is p square. What is f of y? Suppose this is q square, and f of z. So this equals to -1, and then if we differentiate partially, this is to p. This is 2px, and if we differentiate, this is to q. This is 2qy. Okay, so here in the formula we have we need some values, that is in denominator term is p of fp plus q of fq. So what is the value of that? So this is 2p square x plus 2q square y, and second one is what is the value of this denominator term, fx plus p fz. So here we can find this is minus of p square plus p, and another is minus of fy plus q fz. So this is minus of q square plus q. Okay, so you can find these values. Okay, then the Chapet equation, the Chapet equations are, these equations are dx over dz over p f p q f p q f q, and this equals to dp over this minus of fx plus p fz, and dq minus fy plus q fz. ओके, तो जब हमारे ऑफलाइन एग्जामिनेशन में तो ठीक है कि अब स्टूडेंट्स को ये फॉर्मूला ही याद रखना ना मुश्किल है, बट ऑनलाइन में क्या है, ओपन बुक में तो आपके पास सब कुछ वेल रिटन है, तो आपको कोई प्रॉब्लम ही नहीं है, ये सारी चीजें आपको मिल जाएंगी। ओके, तो ये चीजें सारी प्लस पॉइंट है आपके पास कि आपको फॉर्मूले, थ्योरम्स, प्रूफ, ये सारे कुछ ध्यान नहीं देना, तुरंत आपके सारे पास है, इसीलिए बहुत ज्यादा प्रूफ हम करा नहीं रहे। ओके, सो this from which you can find what is the value of here. So this is a dx over what is fp. So fp is this is a 2px, and this equals to dy over this is 2qy, and dz upon 2p square x plus q square y, then dp upon this is minus p square plus p, and dq upon this is minus q square plus q. Okay, so अब इन्हीं को यूज करना है, and you have to find the value of p and q, and then you can find dz, that is p dx plus q dy. Okay, so suppose this is equation number 1. This is equation number 1. Okay, और एक इक्वेशन हमें यहाँ इंटीग्रेबिलिटी से यहाँ से आ जाएंगे, तो हम इस चीज को हम लिखें, सो फ्रॉम विच दिस इम्प्लाइज दैट वी कैन राइट दिस इज p square dx plus 2px dp. Okay, so here we multiply here in this term p square, and in this term we multiply 2px. Okay, and this adding these two, So we have in denominator term, if we multiply here, this becomes 2p cube x plus 2p square x minus 2p cube x. And here we take this dy term and this dq term. If we multiply here, this is a q square dy. So this is q square dy plus 2qy dq. Okay, this upon, if we multiply here, this becomes 2q cube y plus 2q square y minus 2q cube y. So here this term and this term are cancelled out. Here this and this are cancelled out. So here basically this 2p square x and here 2q square y. Okay, so this implies that okay, so in on next page पे हम चलें तो this is p square x plus 2px dp upon this p square x, and if we cancel this 2 and 2 को भी cancel कर लेते हैं, this is simply p square x. Okay, so next page we can write here plus 2px dp upon 2p square x. So this is p square x, 2 will be the cancelled out from the right hand side. So this is q square dy plus 2qy dq. Okay, so this upon 2 is cancelled out. Okay, so this means this thing. So if we integrate this, so on integrating, we obtain, okay, so this is the p square, इसका derivative p square x, and x इसकी derivative होगी 2p dp, so x into 2p dp, so this is your derivative term. Okay, so this means this is your t, so this is your dt, so this becomes log of t, so log of p square x. Similarly here, this is log of q square y, and plus say constant we take a. Okay, so what is a here? So a is your constant. So this implies what is the value here? So this becomes p square x, that equals to a q square y. Okay, because this is a of that, and until logging to both sides, but this becomes this thing. Suppose this is equation number 2. Okay, and what is equation number 1? So equation number 1 is p square x plus q square y, that equals to z. Okay, and here this p square x equals to this thing. So from these equations, this is your equation 1. So from equation 1 and 2, second, we find that this is a q square y, and this is this thing. So this becomes okay, so this becomes a q square y plus q square y, that equals to z. So this implies q square y into a plus 1, this equals to z. So what is the value of q square? Is z over 1 plus a. This is constant one. So q is function of x, y, z. Okay, so here you can write this z is 1 plus a y to the power 1 by 2. Okay, so this is your basically q here. Okay, so this is suppose this is equation number 1, 2. Suppose this is equation number 3. Okay, and from here, this p square x here. This is equation 2. Equation 2 implies p square x. तो हम x को भी ना लिखें, हम equation 2 implies p square, and this equals to a q square y over x. So what is the value of p here? So this is a. What is the value of q square? Q square is z 1 plus a, okay, into y. So this is your q square, and then y by x. This is y by x. So this value is this thing. Okay, y by x. So say y by r cancelled out. So this is az over 1 plus a into x. So what is the value p here? P is az upon 1 plus a x to the power 1 by 2. Suppose this is question number 4. Okay, so then what is dz? So dz is p dx plus q dy. Of course, p the function of x, y, z, huh? And here this q be the function of x, y, z. Here a be the constant one. Okay, so this is your dz. So now we have to calculate this dz and then integrate this over. On integrating, we have find the solution. So on next page, हम चलें. Okay. So next page, this dz, this equals to basically p dx plus q dy. So this p is az upon 1 plus a x to the power half dx, and q is z upon 1 plus a y to the power half dy, and this is dz. तो z वाले टर्म को हम लेफ्ट हैंड साइड ले चले, तो दिस इज z टू द पावर हाफ और z टू द पावर हाफ. ओके, और कांस्टेंट भी कॉमन आ जा रहा है, तो इसको भी हम इस साइड ले लें. दिस मींस 1 प्लस a टू द पावर हाफ हो गए. z टू द पावर हाफ यहाँ, z टू द पावर हाफ यहाँ, तो दिस इज z टू द पावर हाफ, दिस इज dz. और इस साइड में हो गए हमारे a टू द पावर हाफ मींस a by x टू द पावर हाफ dx, और यहाँ हो गए हमारे पास सिंपल 1 by y to the power half dy. Okay, so now integrating, we get, on integrating we get अगर आप इसे इंटीग्रेट करें तो z to the power 1 by 2, तो this becomes a plus half, तो कांस्टेंट ही है. ओके, एंड दिस इज तो माइनस हाफ प्लस 1 करेंगे तो z to the power हाफ हो जाएगा. ओके, डिवाइडेड बाय हाफ, तो दिस बिकम्स 2 हियर. तो यहाँ से भी निकल के आएगा 2, तो 2 हमारे कैंसिल हो जाएंगे. तो दिस इक्वल्स टू a to the power half x to the power half into 2. Okay, and here this is y to the power half into 2. This is the y to the power half. Okay, and plus some integration constant p. So this implies 1 plus a of z to the power half. This equals to ax to the power half plus y to the power half plus b. Okay, so this is the complete इंटीग्रल. आप चाहे तो और सिंप्लीफाई कर दें या सिंपल ही छोड़ दें, कोई दिक्कत नहीं. ऑफ योर गिवन इक्वेशन, दैट इक्वेशन. ठीक है, दिस इज योर फाइनल सॉल्यूशन. तो इसी तरह से आप और कर लेंगे एग्जांपल. ढेर सारी प्रॉब्लम आपको मिल सकती हैं. तो आज इतना ही करते हैं, क्योंकि अब नेक्स्ट स्टार्ट करेंगे, उतना टाइम है नहीं हमारे पास, बिकॉज 10:53 हो ही गए हैं. ठीक है, ठीक है, आज इतना ही करते हैं, फिर कल इसके आगे करेंगे. ठीक है, ओके,
थैंक यू सर. थैंक यू सर.
ओके,
सर